This is my talk on, well, it's actually a talk on Perl in 2030. Stuart McIntosh actually earlier was saying the talk I did about 5 years ago, Perl in 2025, was until a few days ago the top hit on Google for FOSDEM 2025. Because I did that at FOSDEM in 2021. And so that was getting a lot of Google hits. That was good. So anyway, the Perl in 2025 talk started from an advent calendar in 2020. And I turned it into a presentation. As I said, I gave that at FOSDEM. There it is. This is a screenshot of the talk. And here is a screenshot of a screenshot. It's great. So that was a thoughts that I had in 2020, thinking about what might it be like to be writing Perl in about the next 5 years? What kinds of stuff are we expecting? What kinds of stuff am I working on? And a few bits from that have already been done. We've got things like the try-catch syntax that's been in core Perl ever since. Well, it's been in for a little while, but it's now stable. So you just go use v540, and you've got try-catch. There we are. Don't need to use eval anymore. It's great. We've got stable subroutine signatures as of 536. So there we are. You can use v536 or obviously anything later, and you have signatures. So great. Already two things that I said would be happening in, well, it's not even 2025 yet, it's only 2024. So we're a year early. That's great. There's a few more bits in progress. So we've got a lot of the basic class stuff that I've started copying in from ObjectPad. So here you are in 540. You can just make classes like this with this class keyword, the method keyword. The field keyword is a bit exciting. It's kind of the same thing as Rakus has. It makes a variable here that you can just see, and it kind of just looks like a lexical to all of your methods. It has some nice standard behavior to it, so these just respond to constructor parameters and so on. That's all part of the stuff that's in ObjectPad, and so that's been on CPAN for a long time. But as of Perl 540, that's all in there as well, so that's all very nice. So there's just a couple of things that we've already got. Now, the 2025 talk ended with this big slide that said, hey, in the future, it'd be nice to sort of have all of these things. And that talk went off in quite a lot of detail about these things. So this is just a brief summary list. And as of right now, all but one of them are available on CPAN as CPAN modules. They just exist and they just work. I should, at this point out, quite a lot of this work has been paid for by at least 3 of the different sponsors on this list, actually. But I'm going to preserve some mystery, and I'm not going to tell you which 3. But if anyone can guess, perhaps I'll give you a prize later. I don't know, like a cake or a muffin or something. I didn't bring a prize. I just thought it'd be funny. So yeah, anyway, so yeah, these folks have been paying for all these various things. So yeah, all of these things are on CPAN right now. So while this is a talk about what it would be like to be writing Perl in 2030, I will point out most of this talk is stuff that you can do right now, because they're all on CPAN. There's a lot of modules. Most of them live under syntax keyword. That seems to have turned into a place where we can kind of experiment with things that will probably become new syntax in Perl at some point in the future. These are all to do with sort of new keywords that all have kind of custom parsing logic. So they're not just little utility functions. They are proper parser logic that has real power to it. As we've already seen syntax keyword try, we've already seen ObjectPad. Arguably, perhaps in hindsight, I could have called that syntax keyword class, because there's this kind of naming scheme now that pretty much everything just lives under syntax keyword. And so there's a few modules that have weird names, but maybe they should have all been in there. So some other modules that we've now got. We've got syntax keyword match. That's similar to given when, which we're now getting rid of because given when is terrible. The reason this is much nicer is that you tell it what comparison operator you want to use. Like this. So this is a match using the string equality operator against all these cases. So looks and feels quite similar to given when. Probably almost all the times that you're going to use given when. In practice, you know what kind of comparison you're trying to do. So if you just tell it which one you're using, it's really, really simple. Because internally, all that lot just compiles to basically the same thing as you would do with an if-else if. And actually, in really simple cases like that, you can actually just run dpars on the compiled code afterwards, and it literally spits this out. It literally just rewrites it like this. There's a little bit more fanciness internally, in that if you, for example, call a function, it's not just going to turn it into this. It does actually just call the function once, stores it as a temporary, and then does all of this comparison. So it's a little bit nicer than just writing your if, else if. And it's also a lot more obvious to the user, to the reader, because you can look at that and you can see, well, this is obviously a dispatch just on string equality testing, whereas you'd have to read this code a little bit more to notice that that's the same thing. So it's just a nicer way to write that. But that is very much the sort of thing that I would like to put back into core Perl and actually be a nicer replacement of given when at the moment. So that'd be good. We've got some other modules. We've got list keywords, which provides basically the same syntax as the list util functionals, but they're just more efficient. So no great surprises here. You've just got any. It literally behaves exactly the same as list util. It runs faster for complicated internal reasons. There are slight caveats in that you can't put a return inside here because, well, you can, but it'll behave differently because inside there is not an anonymous function. It really is a block because it runs more efficiently. But otherwise, it's basically the same. Arguably, perhaps I should have called it list syntax keyword any, but then it also provides all and none and not all and a few others, and just I don't know. It's fine. We've got future async await, which is very nice. It does asynchronous code flow and data flow and stuff. Here's a nice little example of it. This actually works all the way back to 522. It looks kind of just like writing code. Perhaps I could have called it syntax keyword async again. But again, there's two keywords, async and await. I don't know, whatever. The point of this one really is that it just adds these two little keywords, async and await. Oops, just trying not to point off the stage. And if you ignore those keywords, calling some stuff in a for loop, except that whole thing runs asynchronously. So if you were to call this a bunch of times in different bits of your code, it's kind of all running concurrently. And it's just a nice way to do future-y stuff. And I've got many talks about that. I'm not going to go into detail at all, but it's just another example of the kinds of stuff that we have on CPAN. Now, all of the, oh, where's my slides gone? Maybe a slightly loose cable somewhere. I'll try not to stand over there. We've got newer stuff, newer exciting things in syntax operator, because since Perl 538, we can now do these nice, exciting infix operators. So I've got a few examples of these as well. We've got EQU, we've got in, and we've got zip. So what do those look like? So EQU. So it's an equality comparison that knows about undef. It's a really nice, really simple idea. I really like this one. There we go. String equality that knows about undef. If you give it two strings, it behaves exactly like string comparison. If you give it an undef, it knows that undef is equal to undef. And it knows that undef is not equal to the empty string. And at no point does it print a warning. This is the string comparison operator that you pretty much always wanted. So if you're running 538 or above, you can use this right now. There we go. That's a good reason to update to 538, because 538 lets you do these infix operators. They're very, very nice. I have spent a decade telling people, no, you can't have an in operator because you can use list util. Just use list util any. And then people complained that list util wasn't fast enough, so I made list keywords, which is faster. And people still said, it's too much typing. And I said, no, you can't have an in operator, because how would you specify whether it's a string comparison or a number comparison or any other kind of comparison? You'd need some kind of await. So I came up with hyperoperators in Perl. So here we are, the in operator, in by comparing a number So there we are. If this number is in this list by number comparison, then it matches. And people still said, no, that's too much typing. Why do I have to press the equals sign? Okay, fine. I will let you have it if you can type it. There you are. So you can now have a single character in operator. I didn't say that single character was ASCII. And there's a string one as well. And really all of these are just short, neat writings for in with numerical equality or in with string equality. Those are just two special cases. You can go in with the is_a operator, and you can give it a list of classes. You can use in with the regex match operator, and you can give it a list of regexes. You can give it in with some other custom operator that somebody else could create, and it will work. Yep, you can do in with EQU. Yep, I've got a slide about that later. So yeah, in. So there we are. Finally, after a decade of telling people, no, you can't have an in. Fine, you can have this in, and you will like it. Right. And some more operators, because I do like infix operators. They're lovely. We have zip for composing lists. Very nice. So we have a zip here. So we have a list of things and another list of things, and you zip them together. And what you get back is a list of array refs, and each one of those array refs contains the two things. So you can unpack that like that, which is kind of nice. But in Perl 536, we added the multivariable for each. So it'd be quite nice to have an operator that can actually just directly go into that. So here we are. We have this mesh. I looked around a bunch of other languages like Scheme and Haskell and so on, and I couldn't find a consistent name for this kind of operator. This is a flattened version of zip. So you give it two lists, and it gives you back another list that's twice as big, and it's just got all the elements from both those lists, which are shuffled around in order. So you've got all of the first items first, and then the second items next, and so on. So you get back this even-sized list of key value pairs, effectively. So you can use this with multivariable for each. It's also a great way to initialize a hash. If you have an array of keys, and you have an array of values in the same order, you just mesh them together, and now you've got the key value list that you can just assign directly into a hash. So that's a really nice operator, that. I do like that one, to use that. It's very handy. So these are all nice infix operators that you can get by doing use v538. Very, very nice. More CPAN modules, because I'm not done yet. Somebody brought a bell tree in. Very exciting. Right. That wasn't the 5-minute gong, I hope. Another module that I came up with, and then about a month ago I changed it. I wanted to be able to declare subs with more exciting things. Like I wanted to be able to do named parameters. So I can now do this. So as of, I don't know why I've put use v536. Oh yes, it needs to be 536 because it needs to have the signatures at all. Yeah, so once you're on 536 and you've got signatures, no, 520, that should say 526. This works on 526 and above. Once you're on 526, you can now have named parameters. And so you can just call your function like this, and that does the kind of obvious internal thing where it notices, oh, you've passed in a named parameter called count. I'll just pull it out into this $count variable. And inside the function, you just use that as a variable, and it does all the nice error checking for you. So if you didn't supply a value, it complains because there's no defaulting parameter here. If you pass in other names, it will complain, say, oh, I don't know those names, and so on. Like all of that standard boilerplate code that you put at the top of your function to handle named parameters, it just deals with them now, much like signatures did for positional ones. In fact, this is such a nice idea. I've submitted it, and it's now PPC document number 24, and I'm in the process of looking at actually implementing that in Perl core. So of all of these ideas, that's actually one that's hopefully going to go in. Might get it in for the next one, might not, we'll see. But that's on the way, that's actually coming. So that'll be exciting. I'm going to do attributes in parameters, because the attribute syntax is a great idea that is unbelievably badly implemented, and I need to find ways to make it much nicer. But one thing you can now nicely do with sublike extended is you can put attributes on your parameters. Because one of the things that people want to do sometimes with the signatures is have a function that modifies one of its arguments. Not often, but sometimes people want this kind of in-place trim function, for example, so it won't hopefully surprise anyone too much to know that trim, unlike that, can actually modify the argument you pass into it. It's a bit of a odd example, but it works. Alias doesn't get used very much because really functions that modify their arguments are a bit nasty and rude, but hey, fine. But wait, there's even more. This one, the checked attribute. It's lovely, I like this. You can put value constraint assertions on your parameters. So here we are. Here we have a function that takes this named parameter again, and I'm saying that the count has to be a number. And so if you try to invoke that with a value that doesn't look like a number, it complains. All of this is behavior that happens just by writing this code. I haven't written any of that behavior inside the function. It just checks the value looks like a number and it complains. It's wonderful. But wait, there's even more, because you can also put check on object fields. So these wonderful objects, got this module here, that you can say, here are a bunch of fields. Oh, and when you initialize them, just check that they're actually numbers. So if I want to construct one of these objects, and I pass in a value that, I mean, it kind of looks like a number. To a human, it looks like a number. Perhaps you can put a coercion on that, so you can take the word 20 and turn it into 20, I don't know. But at the moment, yep, doesn't like that. Says, no, it needs to be a number. And again, all of that is behavior that just happens by just writing that. You've not had to write any code. Wonderful. So all of these last two things have all come from data checks. Yet another module. There's a lot of modules here. There'll be a list at the end. Don't worry. You don't have to remember all of these. This is just a quick overview to kind of set the thing. Collection of value constraints. So as we've already seen, there's a thing of a number. And you can say, does this thing kind of look like a number? And perhaps it won't surprise anyone to know if you pass in 1, 2, 3, it says, yeah, it's okay. And if you say hello, it says it's not okay. It's fine. There's a bunch of other ones, numbers, strings, objects, various reference types and things. I don't know if Toby Inkster's around. I should apologize. Hi, Toby. Sorry about this. We should chat about this at some point. We need to align these. But yeah, that's sort of roughly where that's going with that. I decided to call it callable because it doesn't care that the thing is literally a code ref. It just cares, does this thing have object overload? Is this an actual code ref, or does it have object overloading so that I can at least call it? Because this is very much caring about what can I do to the data? How can I use it? Can I use it like a number? Can I use it like an array ref? Because that's what we care about in Perl. And we have these other things like number range and str match. They take parameters, and so you can say, is it a number between 1 and 100? Is it a string that matches this regex? They're all very exciting. We have the any things, and we have all as well. And so you can say, I'm happy to accept any of these things. And any in particular overrides the or, the bitwise or operator. So because people like to put these little pipes in there. And all of that means you can write things like this. So you can allow literally the string nothing or some number between 1 and 100. And this numRange function, I should just briefly point out, I struggled for ages to find a good name for it. That's allowing a number that's at least 0 and not as much as 100. So it's this kind of half open, allows the bottom number, doesn't allow the top. I think I'm going to add, or maybe I've added, I can't remember, a num between that allows both. There's this ongoing thing, like SQL in particular has this thing about, do number ranges include the top limit or not? And they have different syntax for including the top end or not. And it's a bit weird. I've not settled on a good idea yet. So there's reasons why I did numRange like that. I'm not sure I like them, but whatever you do, you're going to annoy half the people anyway. So yeah, whatever. So anyway, so yep, all of that, once again, all just declarative syntax. You don't have to write any code. It just does the thing. And obviously you can put them on fields and so on, and it all works. And at no point did I say the scary T word. So other things you can use those data checks for is this is operator. Because did I say I like infix operators? So rather than calling the check method on these things, you can just use is. And this one is particularly nice because the is operator has a little bit of compile time magic to it. So it just works a little bit faster internally. The things it does to implement this are just much faster than this runtime method dispatchy thing. So it's all just about performance, really. anyone who is a big fan of test more or test two or unit testing, or if you're not, what are you doing here? Might notice there's a little problem here because all of those things have a function called is. And so I allow you to rename these things when you import them. So there we are. You can use the is function from the unit testing, and you can use the is operator and just ask for it to be renamed. And it's nice. It should, you're right. Oh, yeah, it should be is the true. Yeah, very good, very good. See, it's always good to have a bug somewhere in the slides just to check that the audience is awake. Yes, absolutely, absolutely. I mean, I don't have to be awake. I wrote this weeks ago. I'm just reading it out. Yeah, so there we are. We have this lovely is operator. It's very nice. Here's a keyword defer. Now I'm going to do the joke that I always do with this. If you know go, then I'm sorry, defer isn't like the defer in Go. If you know any other language that has defer in it, yeah, this one's exactly like that. It runs the code when you exit the scope. Whatever scope you put it in the middle of an if block, in the middle of a for block, a while block, at a function, at the top level of the program, whatever. When you exit that scope, it runs the defer code. Unlike the one in Go, where no matter where you put it, it always runs it at the end of the function. So they have to be in a function, and you can put it inside many levels of nested scope, and it still doesn't run it until you leave the function. It's a bit weird. Anyway, so we have these defer keywords. They're very nice. We've had them since 5.18, actually. They're in core Perl as well. That's yet another CPAN experiment. And you can put them on try as well, because some people like to write try finally. Basically means the same thing. Nearly done. This one is Tux's request, EQR. It's an even nicer version of EQU because it's aware of undef and regexps, and it's edging its way towards being a smart match, but it's not very smart. It's kind of like my cheap Roomba knockoff replacement. It's got a little infrared sensor on the front. It can see the sofa, and it doesn't bump into the sofa, but it will fall down the stairs if you let it. That's kind of how smart we're talking here. So EQR, you can give it undef, it knows strings, it knows regexps. Anything else, it just compares as a string. It's not super fancy, but obviously, oops, but yeah, it works, and that one works with match case as well, and it's all very nice. So nice little quick tour of what's on CPAN. These are all CPAN-based experiments that you can use right now. They are all possible because Perl 5.14 added custom ops, and the keyword plugin that made most of those possible. 5.38 then added the infix plugin, which has made all of the infix operators work. These are all core Perl mechanisms that currently exist in Perl to support lots of experimentation of syntax and so on in third-party modules. These things are all easily composable because they are built into the Perl core. Primarily, that means they are reflexive. They all kind of know about each other. So you can do match using EQR, as I said. You can do the data check stuff in there. I've got some crazy, scary code somewhere that does, inside an object pad class, it's got an async method that takes named parameters that have data checks and something else. I can't remember. I managed to combine 5 modules. I can't remember what it was. But anyway, they all play together wonderfully well in a way that's much nicer than just parsing it with a regex. Anyway, the other nice thing about them is that they are all individually a static grammar. Each of these modules provides an extension to the parser in a static data structure. Here happens to be a basically copy-paste of the code from match case. It's a bunch of C code that defines a data structure for telling it how the parser works. It's all a bit weird, but it's static. What that means is, once you know this module is being used, that's it. You now know, you don't have to run any code to parse everything every time. You can just turn that into a data structure in the parser or in your syntax highlighter or whatever to understand each of these modules. So they kind of play nicely with syntax highlighting and various other things, or at least they could do, because they're not behavioral code. They're all static. It's really, really nice. So what does this have to do with 2030? So, yeah, so kind of the point of all of this is, here's a bunch of stuff that existed a while ago that I've been gradually pulling into core Perl and that we've basically managed to build. What would I like to do in the next 5 years? Well, first of all, I'd like to continue just migrating a lot of these things into core Perl because that'd be nice. Some of these various people here have already paid me to do some of this. If anything else here looked exciting to you or your company or whatever, and you think you'd like to pay me to speed up the process, do feel free. But yeah, we'll kind of keep pulling a lot of these things into core Perl. We've got the PPC process as well for proposing new ideas in core Perl. As I've said, the subroutine signatures, that's already there. There's a few other things I'd like to do, like match case and any and all, and some of the operators and so on. And then there's a few other ideas that I'd like to do in the next few years as well. Because so far, all of these modules have been possible because of extension mechanisms in the core Perl parser already. I'm starting to reach the limit of what is possible. I've not quite found the limit yet, but getting there. But there's a few more exciting things that I'd like to be able to do that can't currently because things don't exist. So I've got some ideas for more attributes to put on subs that currently can't work because of limits in the attribute system. I'd like to be able to do phasor expressions. I should put a big asterisk on that because I literally this morning on the train may have come up with a way to do these now, and I'll talk about those in a second. But overall, I'd just like generally more extension mechanisms because you've seen how powerful the first few were. I'd like more of them to see what else we can come up with extending the language with. So briefly, my idea for void and scalar attributes, they would force the context of a sub. So here's a function. It's supposed to just print something using say. But if you were to call that as an expression, well, say returns the number 1. Well, actually, it doesn't. It returns true, but true happens to stringify to the number 1. Looks a bit ugly there. What if you could just say, by the way, this sub is void. It never should return anything. Which means when you call it, it doesn't get a return value. That'd be nice. Potentially nice idea. Can't currently do that because of the way attributes work. So I'd like to fix that. I would like some phasor expressions, and I kind of maybe implemented these already. Whoops. The idea is you want to be able to evaluate an expression and inline it as a constant at some time earlier. So like a lot of people kind of do this kind of thing at the moment where you use constant and you kind of define a named constant from some variable, which means that by the time it compiles all this code, it knows that's a constant. It's either true or false. It kind of gets thrown away, and it's a bit nice. But it'd be nice if you could just use begin as an expression. So that there would say, let's compile that at compile time, turn that into a value, and insert it as a constant. That would be kind of nice. But it would be nicer also with things like match case, because the way that match case is implemented, it's slightly nicer internally if it's operating on a bunch of constants. These here, obviously, these are not constants, these are function calls. But if you know your code logic and you know actually those could be constants, it'd be great if you could just put begin like that and say, actually at begin time, at compile time, call these functions, substitute in the value, and now these are constants. That'd be really nice. I'd love to be able to do that. And I would like generally more extension mechanisms. So these are a bunch of slides that were intended for the Perl core hacker conference that we had in April. So I'm only going to go through them very, very quickly. But I'd like better overloading, I'd like better attributes, and I'd like this thing called hooks, which is terribly complicated. Overall theme is to allow more CPAN experimentation. Overloading, yeah. Objects at the moment can try to be strings. Some operations don't currently work in core Perl. So currently in core Perl, there is no way to override the behavior of things like regex matching. So that will stringify it to a plain string and then do the regex match on the plain string, which means you've forgotten your nice, fancy, exciting object type. It'd be nice to be able to allow things like that. So I want to allow more kinds of overloading so that we can actually have objects that behave like strings, because you can't do that in core Perl right now. As I've said earlier, I'd like better attributes to interrupt the parser, to do more exciting things, probably involving magic or hooks or something, just to allow attributes in more places, as we've already seen things like signature parameters. And I've actually got a PPC document for that particular one with the named parameters. But I'd like to allow them in even more places and have a better implementation of them. It'd be quite nice. And finally, this one is way deep into the weeds of the internals, so I will skim over it quite quickly. But Perl has this wonderfully named thing called magic, which is actually a very technical concept. Magic is basically a set of sort of, I was going to say magic hooks, uniquely bad phrase. Magic is basically a set of sort of trigger functions that you can attach to a scalar variable. Bunch of extra functions basically to read it and write it and do a few extra weird management-y things. But ultimately, all of that is about saying, if I try to read this scalar variable, what does it look like? If I try to write into this scalar variable, what happens? It's all about scalar variables. Variables that are scalars. It doesn't apply to anything else. It's a bit annoying because the things that are magic, like some things in core Perl use magic and they don't really need to, they could do simpler things. A lot of things in core Perl, like overloading and tie on hashes and arrays and v-strings, there's so many other things in core Perl that sort of use magic, but have lots and lots of special cases in the interpreter, which means that they're not really using magic. And because they're special cased in the interpreter isn't extensible enough for other people to do the same thing. The interpreter has too many tricks up its sleeve. Yeah, there's a bunch of core internal notes. Yeah, as I said, the special cases, overloading, tie, and v-string, and various other things. It's all horrible. So what I would like is to replace magic with a slightly more extensible mechanism where it just has its own little management-y thing. You could have magic apply to variables, to values, so you can copy them around, because there's places that we want to have like viral hooks on stuff for like data lineage tracking or taint tracking and stuff like that. That'd be quite nice. And then obviously, yeah, you can still have them on scalar variables. And it'd be nice to extend them onto actual arrays and hashes and subroutines and all these other things, and actually put more behavior in so that you could have real behavior on like, say, the time that you compile a function or the time that you use the function and stuff. Like a lot more things that could be implemented in like CPAN modules that we can't do currently because magic isn't powerful enough. So this whole section is basically just saying, I want more power, give me more power. And so that's the plan there. So anyway, got some links here. That's the 2025 talk that I did a while ago. For some reason, these are highlighting in the wrong order. I've got no idea why. That was the original Advent calendar. That's all quite old now, but might be interesting to look at. There's some links. You can see these on the slide. Here's a big long credit roll of all of the modules that I mentioned earlier. And I think with a couple of minutes spare, that will be it. So there's the link to these slides. And from there, you can go back and you can see all the other links. And I will call it there. And probably there's time for questions, maybe one or two. Hello. I did avoid the T word, yes. Threads are terrible, don't use threads. Hmm? Yes, so the talk I did, the 2025 talk, I did that 5 years ago. There are, whenever you talk about types, you get at least 3 types of people, and each type of person has a definite idea of what a type system is, and their idea is totally unrelated to the other 2 sets of people. So if you avoid the T word, you avoid confusing 2/3 of your audience by thinking that you're providing something that they're not. That's why I kept saying value constraints. It's all about looking at a value. Do we like this value? It's all about runtime behavior on the values. It's got nothing to do with, here is a variable and I'm calling this function. Does the source code at compile time suggest that kind of variable is happy in this function. It's not what it's about. It's about looking at the values. So that's why I avoid the T word. About runtime, yeah, but again, it's about the values that the code is working on. It's not about the static shape of the source code. Yeah. Hello. Match case. Match case, yeah. It can do, yeah. Yep. That's why I said it can do. It's got various kind of options to say how aggressively do you want it to optimize. But yeah, if you turn on all the optimization and you give it a bunch of constants, it will turn it into a much more efficient kind of constant dispatch mechanism. And then, yeah, dpars will get very confused. But in sort of some simple cases, it could just be an if-else if, yeah. Currently, you have to tell it because it's a bit experimental, but at some point it'll just be automatic once I'm happy with it. So then we've got time for just one more question, and then we'll call it there. If anybody else has a last one, or if not, hello. Yeah, yes. Yeah. There's a whole huge complicated thing about kind of destructured binding and so on. Like originally I was going to call it let, and then eventually I realized you don't want a new keyword because sometimes you're introducing new variables and sometimes you're just assigning into variables that already exist. And so it should be more of an infix operator, but then the infix operator has to be able to inspect the syntax on the left-hand side of it. It's more complicated than I thought it would be, basically. Like I suggested 4 or 5 years ago, oh, this would be nice, easy, because you could just do it with this keyword. And the more I looked at it, the more I thought, actually, it's really annoyingly hard. Like I've started implementing a few bits, but it's not great. So anyway, so I think that's the end of time. So we will call it there and go off and have a break. Thank you very much.